Hello. All right. So we're going to start where we left off last time, which you can find it in the stream archives. So we left off right here, and we got our image, and we basically are right here. So yeah. Let's get to it. This is probably going to be a short stream. Just gonna do like the all of this section 3 stuff, which is just basically creating vector 3 thing, and then yeah, pretty much that's it. Alright, so adding a progress indicator 2.3. Before we continue, alright, so basically we're doing this printf. We're gonna do, what is /r? I'm gonna see what that is actually. So I've never used that. Scan lines remaining. And then we'll do h minus height minus height minus h, got the difference of that, and yeah, we're gonna want percent %d probably, and let's see how that goes. That's very simple. Alright, now we're on to the vec3 class. Let's see. First, I gotta see how this runs. Yep, and it just eventually, it does everything. Does all of the scan lines. We have 256 scan lines, and we start at 256 and we get done, and boom. So that's pretty alright. /r doesn't seem to do anything that I know of, and I'm not going to look it up right now. Probably does do something. Alright, the vec3 class. Almost all graphics programs have some classes for storing geometric vectors and colors. In many systems, these vectors are 4D, 3D plus a homogeneous coordinate for geometry, and RGB plus an alpha transparency color channel for colors. For our purposes, 3 coordinate suffices. We'll use the same class vec3 for colors, locations, directions, offsets, and whatever. Some people don't like this because it prevents you from doing something silly like adding a color to a location. They have a good point, but we're going to always take the less code route. Okay, basically just we're going to create a vec3 class. Alright. Yeah. And I'm not using C++. So we'll create our own vec3 thing in its own thing. Well, basically, it's probably just going to be struct like vec3.h. Seems good to me. Alright. Let's see what he has going on here. he has basically want I'm probably going to do my own thing here. We're going to do strive vec3 type def. I'm just going to do that for fun. Doesn't mean anything. In fact, I'm not even going to. Right. Vec3. It'd help if I actually typed. If I was able to program. F32 XYZ, right? And yeah, that's basically it. Oh wait, this oh, these are doubles. Okay. 64. Alright, now we'll start working on all of the functions that we want. Right? This is all C++ class stuff. Dude. C++ code is so messy. I have to break this down in my head mentally. Let's see what's going on. Alright, let's go line by line here. Getters and setters, or just getters. I don't need getters. And operator minus. So that's basically so it's going to return a vec3 negate, right? And it's going to take in a vec3 x, I guess, whatever. And basically just going to go ahead and say, right, new vec3 x, I guess, I don't know. And then x is equal to expected an expression. Or let's just call this vec, or v, just call it v, right? And then this, okay. So is equal to v dot. Is there a problem here? I think that the IntelliSense is broken or something. Yeah. All right. So let's just do this. V dot x is equal to v dot x minus, and we'll just basically do that for the y, and then the z, right? I just realized I should. That should be better audio. Actually, I forgot to turn my fans off. Okay. So now we're gonna see what we got next. That. Yeah. So we're gonna do we have to return new movie, right? And now I'll create another one called add to add. Okay. Right. And this will take in Vic3v, and we'll have another Vic3v, and we will let's see, plus equal this stuff right here. V dot x plus equals v dot x, right? And same thing. X, Y, Z, and turn V, right? I just realized I'm completely stupid. This needs 2. I'm just not smart. Dang. Alright. So, alright. So V equals V plus, or, oh my god. I hate this. Let's see, okay. Plus equals V2 dot X, right? And we'll do that type thing, right? Okay, no. Alright, let's go this way then. Just do it manually, because I can't actually use Visual Studio. Terrible editor. Alright. Well, that was fixed. So where were we? Let's do, let's see, what is this? God. Alright. Let's see, what do we got on the list for next? Time. I'm going to do a different version of this too. Right. So we're going to do a pointer versions of this to make it easier. Because right now, what you would have to do is you would have to do, okay, like vec3 v equals add v and then e, right? Let's say e is a vector 3. But if we did like a pointer version, you would only have to do like add ve, right? And it would automatically plus equal e onto the v values of ve. It would save code. But both versions are useful for certain cases, I guess. I don't know what to name different ones, but let's do subtract, and then we'll do vec3v1. You know what I could do? I could probably just copy this, right? Okay. And then we would just want to minus this, right? Okay, now just do multiply, right? And that would just be times. If I okay, dude, I cannot type apparently. This is probably going to be a boring stream, just doing Vec3 stuff for now. Next time, we should get into something more interesting, but for the time being, this will have to do. Right. We'll get into rays next time. Okay. This is very... Alright. And then let's go ahead and make a whole new version of this, right? Let's just call it P, negate P for pointer. Right. Let's do void, right? Pointer V. V negate. Or negate. I don't know, man. Let's do negate V. Why not? After all, I'm the only one going to be using this anyways. What's going on? Freshen myself. Because that looks ugly. Or, you know what? If I was actually smart, I would have done that. Dude, I'm just not smart. We don't want that, actually. And then, alright. Just a small thing I had to deal with. Let's go back to it. Right. And then we'll just do void of that. And we'll just do V, right? And then vec pointer v1, and then we'll do that for this one, right? Actually, let's so we don't want this anymore. It's just right. v1 this, right? Plus equals that. Void add v, and then we'll do subtract, and then right. All right. All right, well, let's just do another one then. That was a very long pause. I'm terribly sorry. Multiply. God, I hate. Okay. Visual Studio. I'm blaming it on Visual Studio. I'm just terrible at everything. Let's see. Divide now. Did I say that this was going to be a boring stream? I think that I did. I haven't failed you yet. Let's refer to the old thing here. So what I'm going to do now is I'm going to
Yeah. I love you too.
Alright. Dude, C++ is just so messy. I can't even... Dude. Alright. Divide equals is so what I'm going to do is I'm going to have a scale. Right. Vec3 scale by vec3 or by vec3 v, and then what we're going to do is like a double, I don't know, s, right? It's for scale. This is all in a header file. I might want to separate this out to a C file eventually, but for now, it's no problem with it. There is a problem with that though. Now we're gonna make this function or something. I don't know. Vectory v and return v, right? V equals v dot x times s, or v dot x. Right, and dot z, right? Dot z, dot y. That looks good to me. Now, all right. So I've decided it's probably all of the functions that I'm going to need. Probably. Right. Scale. Times equals let's see. Dude, why am I so tired already, bro? It hasn't even been 30 minutes, basically. I'm already tired. Yeah, 42 minutes I've been streaming. Dude, operator overloads are good when you're using them, but when you're reading them, it's wicked confusing because there's no English words to describe what's happening. So you have to, like, actually know what you're doing. Like, imagine knowing what you're doing. That'd be pretty crazy. Alright. I'll say that's fine. And then we'll just do a double, right? Fine. Squared. Fine. Squared. Vec3 v. This will actually probably be. No. We don't need to apply this to the value. This is probably not going to be applied directly to the vertice or vec3. Right. So let's go ahead and v dot x times v, or return v dot x times v dot x plus v dot y plus v dot y, times okay, thank you, v dot z times v dot z. Alright, that seems like good enough, right? Excuse me. Alright. So now we're going to do double length, right? And we're going to take in vec3 v and return square root of length squared d, right? Square root doesn't exist because I think math.h, right? Say that's fine. Probably made mistakes there, but whatever. And now it wants me to create utility functions. So yeah, I guess we'll do that, right? Sounds like a smart idea to do. I don't particularly like the way they write code in this book, but hey, I was told it was a good thing. So we'll keep on doing it until maybe a few weekends from now we can finish Raytracing in one weekend. It's my fault because I only stream Fridays, so let's go ahead. So I'm going to actually do that last. Basically already did all of this. dot product is something that we need to do. So we'll create double dot product of this, and it'll take a vector 3 v v1, and then a vector 3 v2, and then we'll just so we'll return. Let's create a new vec3 v, and we'll return v. And compiler should optimize this, obviously. So I'd say that it's alright to do, unless I'm mistaken, but I don't really care if I'm mistaken. That guy, why are you not? What's wrong with this? Oh yeah, never mind, actually. I don't know what I'm doing. Let's see. So we want v1 dot x times v2 dot x, right? Plus v1 dot y times v2 dot y plus v1 dot z times v2 dot z, right? And that is what we want. Then we want the cross product. Cross vector 3 v1 vector 3 v2 return. We'll create vector 3 v return v, and we'll basically say that it's going to take some brain processing power. Okay, so v dot x equals v1 dot x or dot y bro, I don't like the way that he makes his things. Makes it like, I don't know, like people, a lot of C++ tutorials, I feel like they try to make their code as hard to read as possible just for fun. Rant over. Let's get to work. Oh god. v1 dot y times v2 v2.z. What the? Wait. Wait, what? Alright. Dude, I'm gonna have a headache. Alright. And then I think that's how that goes. And then we're gonna do the opposite of what we just did. And we're gonna do v1.z times v2.y. And I think that's what's happening here. Probably not, but we'll go ahead and see if it works eventually. Maybe in the future we make a terrible mistake, but we use our math functions and nothing is working right, and we're like, oh man, maybe we messed up our math functions. It's probably what's going to happen, honestly. No, wouldn't be surprised. Alright. V dot y equals v1 dot z times v2 dot v2 dot x. And it's going to be x dot z. Alright, yep. And then we'll do c again, right? v1 dot oh, I'm sorry. Alright. v1, v2 dot y. Okay. Because we want that. And then we're going to go with that. v1 dot x, right? And then no, x and then y, right? That's what we want. That's what we want. I think that we've done it. Or something. Maybe we didn't. I'm going to pretend that we did, though. And then do vic3 normalize. And then do vic3 normalize, which is basically a unit vector. Vec3v return v divided by v dot length, or no, v divided by the length of v. Oh yeah, I forgot. Let's see, divide. Let's create a function vec3 divide divide by vec1 d, and then say double s, I guess, or Yeah, sure. I don't know. Right. And divide by the length of v. Right. And yeah. I will go take a bathroom break, and then we'll get on to our last section of the stream, which is color utility functions. Okay, let's get back to this and let's finish this off. We just did all of this. Hopefully you see what I mean by making the code as confusing to read as possible. And if you don't, it's probably just me not being smart. So we are on color utility functions. And this is not meant to be an educational stream. I'm not supposed to be teaching you to do anything, because I can't. I'm just doing this for fun, right? Someone to watch me. Alright. Okay. Alright. So let's get back to this again. I want to finish this off for tonight. Let's do type def. Vec 3 is color. Right, color 3. It would help if I actually did this correctly. Alright, and then we can do color 3. And then you got 3. Okay. So, Well, yes, let's do what we were supposed to do, which is create another file. I hate. What? Why? No, stop. Okay. Create a new colors header file. Color.h. This actually makes sense to be put right here. Okay. Let's include our new vec3.h file. And vec3.h, and we'll just do like something like this, type def. I spelled that wrong every time. Okay. Vec3 is color 3, right? Right. Right. Color. I don't think that needs to be color 3. Or I could just do RGB, right? You know, we already have that. Visual Studio breaks. Wouldn't be a day without that happening, wouldn't it? Alright. RGB. But we also have RGBA. And what we could do is we could write a vec3 utility that says, okay, vec3 to color. No, we couldn't. Actually, that's not a good idea. Just this tutorial does things in such a weird way, like using the stream system. Like, what? No one uses the stream system? Are you kidding? Like, for hashtag include color.h, right? I don't think that I need that right now. right. Let's right. Color pixel. Or we'll call this right pixel. Right pixel. And then an RGBA color. And we'll just say, alright, pixel. Oh god. Alright, well, I'm being interrupted like every single second today. No, please don't break. Okay. So our R is going to be color.r. Am I wrong? Like, oh, yeah. That was stupid. Pixel RG is equal to color dot G. Pixel B is equal to color dot B. And pixel A is equal to color dot A. Right. Pixel. Pixels. Pixel. And then pixels, take that address in, and then we'll take the color, take the address of that. I don't know if that'll actually work. It might. I have to think about that. Or maybe I don't. Maybe I can just run and see if it'll work. Let's see. What if we switch this to height and this to width? Just to see what happens. Let's do RGBA of .r is equal to R dot G is equal to B G dot B is equal to B dot A is equal to A. or an A is equal to 255. Dereferencing no pointer pixels. Get that all the time. Open folder. And let's see how our picture is going. Alright, well. It's not actually existing. Time size of RGBA. Exception thrown axle. Oh my gosh, bro. I don't understand. You know what I could do? Instead of going through all this trouble, dismiss this as a awful thing. And I could just say RGBA, right? Pixel, RGBA, and then we could do car, R, car G, car B, even car A. Care, car, char, character, care, car. I just typed message, say car. I don't know why. And then we'll just return RGBA, right, of, let's say RGBA, and that should work, right? So instead of that nonsense, we do RGB 255 is this isn't actually writing a pixel. I should probably name this to return RGBA. Right. Oh god, okay. Alright. Pixels, pixel equals RGBA. This was an incredibly boring stream. And it doesn't look like it'll get much interesting there. Or a lot more interesting until a while from now. I guess we'll just have to start slow and work our way up. Right? So it usually works. You know what? You know what might be the problem? That wouldn't be a problem, actually, and that wouldn't have affected the image. I don't know what I was thinking. What am I doing that's so awful? Dude! Dereferencing no pointer pixels. Like, excuse me? I don't understand. What's your problem? You were working, like, the other time. You know what? I just realized that I'm not smart. Again. Oh my gosh. Bro. I make some pretty stupid mistakes all the time. Alright. Now I expect a solid image. I get one. I would like to open file location. Right. So all this time it was just me being stupid, like usual. And I think that might be the end of the stream. I am all good. I'm all good for today. Well, we got an image, same image as before. We basically wasted a bunch of time converting messy C++ into pure Christian C. Nice and pure. Absolutely no atrociousness. That's it. Alright. Nice.